Welcome back, ladies and gentlemen, on this fine Wednesday afternoon. It's a clear sky, about 65 degrees outside on this beautiful Wednesday. So go ahead and copy this down. We're looking at section 7.3, multiplying and simplifying radical expressions. Stay tuned. Your radicals are coming up next. All right, folks. So welcome back. Let's start off with a nice little example here. All right, so I can give you a little sneak peek at what is going on here. So notice, just like the introduction said, we are multiplying our radicals. And some little things I want to see here. So I'm going to add some language here. So my radicals have an index of 2 each. So each of those indices are 2. What does that mean? All right, let's tell him, Johnny. What that means is we are allowed to multiply both of our radicands. That's what's inside. So whenever you have the same radicals, right, with the same index, you're allowed to multiply whatever is in the inside. So all we do, we multiply and we get that 35. And that's going to be the big idea today. All right, that's going to be the big idea today. So let's just make sure this is clear. Notice, it doesn't matter what your index is as long as, in this case, there's 2 of them, so your indices are the same. All right, so let me just put some numbers in here. And according to what we said, okay, let's go check. That's a 5, that's a 5. Awesome. So now we could go ahead and multiply what's on the inside, which is called our radicands. All right, so let me make a mistake here. Let me multiply. I'll get 27. What's the mistake I just made? Good. You heard that girl in the back? She said, go ahead and do not forget to write down that 5. The index has to come along for the ride. Okay, so that's going to be the big idea today that's going to carry us through everything. All right. So since I heard such great reviews last class, what we're going to do is we're going to say these examples are from 7.3, and these are going to help us with exercises. These are going to help us with exercises 1 through 20, these first examples that we're doing. All right, just so you could kind of put that in your notes, and hopefully that helps you as you're going along with your homework. All right, let's do another one here. Let's take a little U-turn here. All right, so let's go with the 6th root of x minus 4, and let's multiply that times the 6th root of x minus 4 to the 4th power. So notice, if there's no parentheses here, this x minus 4 is really to the 1st power, right? There's an invisible 1 right here. So we look at our indices. I got a 6 here, 6 here. Fantastic. So that tells us we are allowed to multiply whatever's in our inside here, our radicands. So we can multiply those two. So let's go ahead and do that. And since they both have the same base of x minus 4, all we do is we look at their exponents. I got a 1 here, I got a 4 here. We're multiplying. So remember, when you're multiplying, you go ahead and add those exponents. We added those exponents when you multiply. Same basis. So make sure that's clear and in your notes. All right, so that later on, it might make sense right now, but later on it'll be like, wait, what just happened? All right. Any questions on that one? No? Fantastic. All right, let's continue the march here. Let's get another example under our belts. Let's go with, I'll go with number 18 from your homework here. So this is number 18 from that same section. Let's go with the 4th root of x over 3 times the 4th root of 7 over y. All right, so am I allowed to multiply these? Good, the answer is yes. because they both have an index of 4. So now we multiply what's on top with what's on top. So you're left with 7x, and you're going to multiply the denominator times the denominator. So you're left with 3y. We can't simplify that, so that's where we stop. All right, so notice in these first examples, we went and multiplied what was inside um, our radical, which is called, we multiplied our radicands, right, using that vocabulary, and then we got our answer. But of course, what we practiced last class is reducing. So that's what we're going to do today. All right, we're going to see, all right, what happens when you can reduce? So let's take a look and let's see what happens. So now we're going to go ahead and we're going to jump and we're going to look at exercises. So these examples are going to help you with exercises. Let's go 33 through 38. All right, so let's start off slow here. Let's start off with example 34. So this is number 34 from the textbook. So what we have is we have this function, f of x equals the square root of 81 x minus 2 squared. All right. So we're going to simplify this. So go ahead and write that down. We're going to simplify this. All right. So what is the square root of 81? Well, nice. That's just 9. And what is the square root of something squared? What's going to happen with each of those pieces? Well, they're going to cancel. So all you're left with is x minus 2. Right? The square and the square root, they cancel each other. So that's what we're left with. So if you want to make a side note, right? Let's say we have something squared. Say you have y squared, and then you square root that. So the square root and the square, they're the inverse functions of each other, right? So they cancel each other out. So you're just left with y, right? Let's do another short little example just to kind of help make sure it makes sense. Let's say I have a w plus 1 and that's squared. Well, what's going to happen? The square root and the square cancel each other out, so all you're left with is this w plus 1. And last class we said make sure it's an absolute value, but today what we're going to do is, because we're getting our introduction into these problems, we're going to, on some of these, we're going to assume that they're positive numbers. But right now, we don't know if they're positive. That's not given. So because we don't know if they're positive, notice this piece we have the absolute value. So let's go ahead and let's stick this x minus 2 inside the absolute values. So I don't even need that parenthesis. So it should look like 9 absolute value of x minus 2. All right, because again, they don't tell us that x is a positive number or that x minus 2 ends up being positive. All right, let's do another one. Let's go with f of x equals, let's go with the cube root of 48 x minus 2 cubed. All right, so 48 unfortunately is not a perfect cube. So what we're going to have to do is we're going to have to break down this 48. We're going to have to break it down into one number that is a perfect cube and the other number is not a perfect cube. So what do I mean? Let's go ahead and do this. So the 48, what I'm going to do is I'm going to change it, rewrite it so that becomes 8 times 6. And the 6, let me make it red because the 6 is not perfect. All right. And the reason I broke it down into 8 times 6 is because 8 is a perfect, so 8 is a perfect cube. I know the cube root of 8. What's the cube root of 8? It's just 2, because 2 times 2 times 2 equals 8. And this x minus 2 cubed stays the same. All right, so now I could get down to business. We said the cube root of 8 here, that gives us 2. The cube root of x minus 2 cubed, well, the cube and the cube root cancel, so you're left with x minus 2. You don't have to put that in absolute values because this is not an even exponent. And notice that 6, I can't break out into 6, so the 6 stays inside of the cube root. All right, so I can't break down that 6 any further. So this is what our answer looks like for that one. All right, so let's continue the march here.